All right, welcome to today's lesson. Today we're going to write equivalent fractions and fractions in simplest form. That's what we're going to focus on. Here's your warm-up. I want you to come back when you found all the factors of each of these numbers. List them all. See you in a little bit. Good luck. All right, so hopefully you were able to get the same answers as I did. Take a look up on the board or on your screen and make sure that you have the same number of factors on your page. Okay, now that you're warmed up, let's get into today's lesson. So we're going to be looking at equivalent fractions in this unit. And we know that we've used rulers, and I know we've used rulers before. And rulers often have these little marks, these little lines from the difference between 0 and 1 inch, 1 to 2 inches, 2 to 3 inches, and so on. All those little dashes are fractions of a whole. So they're parts of a whole. So let's review quickly what we mean by parts of whole. Here, we have some notes in the bottom I'm not so worried about, but this I want to make sure you have in your notes. So let's remember that with a fraction, there's two parts. There's the numerator, which is the top, and there's the denominator, which is on the bottom. And they're separated by this fraction bar, which can also be a division bar. But the way that I remember numerator and denominator is I think of N for north, D for down. So with a fraction, remember the numerator is the parts of, and the denominator is a whole. So the whole is how many pieces it takes to make one whole thing. So if you think about a pie or you think about a cake, you have one whole pie or one whole cake, but usually you cut it up into as equal amount of parts as you can so that everyone can get an equal amount. Now you're breaking it into how many parts it takes to make one whole. So remember, all parts in a fraction must be equal. Now, let's get into how we can work on this with our first problem. And actually, before we do that, I have one other set of notes I want us to get into, and that's what an equivalent fraction actually is. So here's the definition of an equivalent fraction. Fractions that represent the same value, but all the fractions look different. So here I have a picture showing, think of it as a big pizza. We've taken a pizza and cut it into just 2 pieces. Then we took a pizza and cut it into 4 pieces. Then we took a pizza and cut it into 8 equal pieces. Now in all 3 of those pizzas, how much is actually shaded? Purple or pink or whatever this is. You'll see one whole side of it is shaded. So even though the fractions may look a little different, you have 1/2 or 2/4 or 4/8, they all still have the same value. So fractions can look different, but they might still actually have the same value. Have this down before moving on. All right, so to help you understand here in example 1, I drew some drawings here of equivalent fractions. It wants us to find 2 equivalent fractions for 10/12. Well, one way is you can draw a rectangle and you can cut it into equal pieces. So we did that first with 10/12. We made a square with 12 pieces and we shaded in 10. Well, if we change the lines up just a little bit, but you make sure everything is still equal like we did here, we're able to take that same square and cut the pieces into 1/18. So how many pieces will need to be taken to make one whole rectangle here? That'd be 18. That's why 18 is on the bottom. That's how many pieces you need to make a whole. But shaded blue or purple, we only have 15. However, that is the same as 10/12, just looks different. 5/6 is the final one. You can see we have 6 pieces and 5 are shaded. So one way to represent equivalent fractions is to do some drawings and be able to show how they actually are equal. The other thing I want you to look at is how do we go from 10/12 to 15/18? And how can you go from 15/18 to get 5/6, yet it's still the same? Well, one of the ways you do this is you find a number that you can multiply them both by to have an equal number. That's what we're going to start to get into a little bit. Let me show you with the next problem. Make sure you have this down before moving on. Now, the 2 simplest ways to find equivalent fractions besides drawing is taking the fraction you're given So here, in this case, it's 4/6. And remember the note I had when we looked at what a numerator and denominator is. Both parts have to be equal. The phrase I like to say is what you do to the top, you got to do the bottom. Or what you do to the numerator, you got to do to the denominator, or vice versa. So here, the easiest way to do it is find a number that you can multiply by 4 and 6 that's equal. Well, I can multiply 4 and 6 by 2. So if I multiply by 2, what I do to the top, I got to do to the bottom. So what does 4 times 2 give me? It gives me 8. And what does 6 times 2 give me? It gives me 12. So one easy way to make an equivalent fraction is multiply the numerator and denominator by the same value. The other way that you can do this is to divide. So if I look again, I'm going to rewrite this a little bit. Let's say we have 4/6 again. I can find a number, if possible, to divide 4 and 6 by equally. Well, since both are even numbers, I know that I could divide by 2. And what I do to the top, I do to the bottom. So 4 divided by 2 is 2, and 6 divided by 2 is 3. That's another way you can show how you get equivalent fractions, by multiplying or dividing by an equal value to both the numerator and denominator. So that's how I was able to take 4/6 and make 8/12 and 2/3, which are both equivalent fractions to 4/6. I would encourage you to copy down the little problem that I did with the math, not the drawings, but the math part, so you have an example of how you can multiply and divide. And again, you could multiply any number you want. You can multiply by 2, multiply by 10, multiply by 5. It doesn't matter, as long as what you do to the top is the same at the bottom. The dividing, however, you're basically looking for the greatest common factor. That's why we learned all those factor things, to be able to find a number to divide by. All right, let's get into some practice. 4, 6, 8. Okay, here are 8 problems I want you to find equivalent fractions for. So again, the easiest thing to do is you can just simply take, since we got to do 2, take the numerator and the denominator, multiply by 2, and then multiply by 3. If you do that with every single one of them, it shouldn't be too hard. For example, the problem 13 here, let's say I multiply the 3 and the 9 by 2. One equivalent fraction here then would be 6/18. Okay? That gives us the same value as 3/9. It's equivalent. Or I could take the original problem and multiply by 3. So 3 times 3 is 9. And 9 times 3 is 27. Both of those are equivalent. So that should help you when working through these. Good luck finding equivalent fractions as you move forward. Now you could have possibly had different answers to make your fractions equivalent, but all I did is that same thing I showed you with the first one. I multiplied the original fraction by 2, the numerator and the denominator, and then I multiplied the numerator and the denominator by 3, and these are the answers I've got. Now some of these you could have found the greatest common factor and divided them by each other. That would be great if you tried some of those, but we'll get some of that practice as we move forward. Okay, let's move on. So in practice 2 here, or example 2, we're just using the same kind of thing I was kind of showing you in practice 1, or example 1. So let's say we had a missing value, and we had to find what that missing value was. Well, we know that we're trying to find an equivalent fraction because we have this equal sign here. And equal signs mean that what's on one side has to be equal to the other. Now here's where knowing your math facts will make this stuff a lot easier. So you use what you already know. So we don't know what this number is here, but we do know that straight across from it is 3. Now on the bottom, on the denominator, we have 5 and 20. Now remember that fractions are equivalent. So what you do to one, you can do to the other. So take the stuff you do know and figure out how many times you have to multiply 5 to get 20. If you know your multiples of 5, you know that it's 4. 5 times 4. And again, what you do to the bottom, you're going to do to the top. So now you're just going to do 3 times 4. 3 times 4 gives you 12. And that's how you get 12/20ths as an equivalent fraction. So you use what you already know to be able to find the missing value. Let's look at another one. Now either the last one or this one, I want you to write them down. But let's look at this one. This time we have both numerators. We got to find the denominators. So again, how do you go from 4 to 80? You got to know your multiplication facts or your multiples. I know that 4 times 2 will give me 8, and then a 0 in the ones place value would tell me 20. So what you do to the top, you do the bottom. 5 times 20 gives you 100. So the equivalent fraction of 4/5 here would be 80/100. Okay, hopefully this is catching on a little easier. All right, here's another one where we have 3/9 equals what 27ths. So we know the bottom parts. We know 9 and 27. What do you have to do to get from 9 to 27? We're getting bigger, so again, we're multiplying. 9 times 3 gives me 27, so what I do the bottom, I do the top. 3 times 3 gives me 9, and that's how you find that missing value. All right, let's get into some practice problems here. I have several problems I want you to solve. You got to find the missing value, either the missing numerator or denominator. And I'll do 21 with you. So again, we have 3 and we don't know what, and we have 7 and 35. So since we're getting bigger, we know we're going to multiply. How many multiples of 7 get you to 35? That would be 5. So what you do to the bottom, you do to the top, and 3 times 5 is 15. So the answer you're going to want to write down is 15/35. Okay, good luck with the rest of them. Come back when you're done. All right, so all you had to do is find the numbers that you either had to multiply by if the value got bigger, or a number you could divide by, the value got smaller. So here's the answers that I had, and I hope yours match as well. If you got all these right, come on over and give me a high five. Now our clear goal of fractions is we always want to try to get them into simplest form. So what is simplest form? It's a fraction. In its simplest form is where the greatest common factor of the numerator and the denominator is 1. So if you can get it as low to 1 as possible, if your numerator can become 1, you found it. So I'm going to show you how to do that in the next step. Make sure you have the definition down. Okay, I'm going to show you two methods. One is the one that you'll probably always use. Another method you may enjoy, especially if you're really good at prime factorizations. So let's say we were given the fraction 20/48. Well, to put it in simplest form, the one method that works the best for people is you got to find the greatest common factor of the two numbers. So if you go to find the greatest common factor, remember the trick that I showed you is find all the factors of the smallest number. In this case, it's 20. So we got 1, 2, 4, 5, 10, and 20. And all you got to do is divide, starting with the largest number into 48 and seeing which one you get. 20 doesn't go into 48, 10 doesn't go, 5 doesn't go, so your greatest common factor is 4. That's the number you're going to divide them by because you want to try to get the smallest numerator and the smallest denominator possible, but you have to make sure what you do to one, the other can have too. So 20 divided by 4 gives you 5, and 48 divided by 4 gives you 12. That's one method and probably the most common method to use. Now, some people may struggle to find the greatest common factor. As long as you can find a common factor, that will work too. For example, you may not notice 4 works, but they're both even. So you know you could divide by 2. So if you did 20 divided by 48, or 20 and 48, and you divided by 2, so what you do to the top, you do to the bottom, you know you simplify down to 10 24ths. And then you'll look at it again and go, oh, they're both even again. I could divide by 2 again by both. 10 divided by 2 is 5, and half of 24 is 12. Again, you get the same answer. It just takes you another step. Okay? Let me show you how you can use prime factorizations to solve these as well. Make sure you have this down before moving on. All right, so here's how you could use the same one to use the prime factorization method. So what you could do is you could write the prime factors of 20 and 48. So the prime factors of 20 is 2 times 2 times 5, and 48 is 2 times 2 times 2 times 2 times 3. It's best if you don't use exponents for this and you just write it out longhand. So the first thing you're going to want to do is cut out the ones they have in common. They both share a 2. They both share another 2. And now you look at what's left, and that becomes your numerator and denominator. So for the 20, all that's left is a 5. 5 goes there. 2 times 2 is 4, times 3 is 12, and 12 goes there. So this method works as well, and it's very useful when you know that the numerator and the denominator have common factors. But if you're not sure what the greatest common factor is, this method will help you. Plus, if you go ahead and you look through it and the prime factorizations don't even share anything that's common, it's probably already in simplest form. So if this looks like a method you'd want to try, go ahead and copy this down. If you're looking at it going, that seems a little difficult for me and I may get confused, don't even worry about it. Let's move on. All right, so let's say you were given the fraction 7/10 and you had to put it in simplest form. Again, you're looking for the greatest common factor, so you take the smallest number and you list the factors of it. Well, since the top number, which is probably going to be your smallest number, is 7, we know 7 is prime. When you have a prime number, the only greatest common factor you'll have between the two numbers is 1. There's no way we can simplify 7/10. They don't have anything else that goes in common besides 1. So, in this example, 7/10 is already in simplest form. All right, let's take one more, and I'm going to use the greatest common factor method with this because it seems the most common for me. But I'm going to do it in a little different way. So I'm looking at 12 and 16. I don't know what the greatest common factor is, and I struggle with that, but I can identify that both are even numbers. You can take both numbers if they're even and divide it by 2. So 12 divided by 2 is 6, and 16 divided by 2 is 8. 6/8 is smaller, but again, I'm looking at it and going, the 6 and the 8 are both even. I can divide both those by 2 again. And 6 divided by 2 is 3. 8 divided by 2 is 4. Now, if I look at it, the numerator is a prime number, and that's how I know that I'm done. 3 can't go into 4. There's no number that they share that's common as a factor except for 1. So that's how you're done with it. Okay? Now, again, it's a lot quicker if you can find the greatest common factor like we did down here and be able to solve it that way. If the prime factorization method works for you, this is how you do it. The prime factorization of 12 is 2 times 2 times 3, and 16 is 2 times 2 times 2 times 2. So they both share 2 sets of 2, so you cross those out. Now the numerator, all that's left is a 3, and the denominator is 2 times 2, which is 4. So another way that you can do the work, whichever one you feel most comfortable with. Okay, and again, here's an example where it's already in simplest form. The greatest common factor of 3 and 10 is 1. You're going to have these sometimes where it's already in simplest form. So you have 2, 4, 6, 8 problems to do. I'm going to help you with 29. Remember, finding simplest form, so we got to find the greatest common factor. Well, the factors of 2 would be 1 and 2. So start at the top with 2 and see if it goes into both. Obviously, it's going to be dividing by 2. So 2 divided by 2 is 1. And what you do to the top, you do to the bottom. 8 divided by 2 is 4. So the simplest form of 2/8 is 1/4. Good luck on the rest. Come back when you're done. We'll see how you did. So pretty common out of most of the greatest common factors was 4. Found that interesting. Happened several times. But here are the answers you should have gotten in getting them down to the simplest form. And as you can see in simplest form, for every single problem, the numerator is a prime number. That's your ultimate goal. All right, now that we got through all our practice problems, it's time for us to get on to the box of thought. We'll skip past that. So you have 3 questions. Answer them to the best of your ability in your notebook. All right, and here's your quiz. You got 6 problems. Go ahead and use what we learned in this video to try to answer all of these. All right, that's it for our lesson. I guess we'll call it quits, and we'll see you next time. Way to hang in there.